Bismillahirrahmanirrahim. Assalamu alaikum students. My name is Afia Farooq, Divisional Public School and Intermediate College, Lahore. Welcome students, chapter number 1 and the topic is quadratic equations. Students, in your previous lectures, you have learned about equations reducible to quadratic equations and different type of equations. These are type 1, the equation of the type ax4 plus bx square plus c is equal to 0. Type 2, the equation of the type a into p of x plus b over p of x is equal to c. Type 3, reciprocal equation of the type a into x square plus 1 over x square plus b into x plus 1 over x plus c is equal to 0, or that can be written as ax4 plus bx cube plus cx square plus bx plus a is equal to 0. Type 4, exponential equations of the type 5 raised to power 1 plus x plus 5 raised to power 1 minus x is equal to 26. And type 5, the equations of the type x plus a into x plus b into x plus c into x plus d is equal to k, where a plus b is equal to c plus d. All these types you have learned in your previous lectures. Now, in this lecture, we will learn about radical equations. There are 3 types of radical equations, type 1, type 2 and type 3. In this lecture, we will learn about type 1. Radical equations. An equation involving expression under the radical sign is called a radical equation. Example given, square root of x plus 3 is equal to x plus 1 and square root of x minus 1 is equal to square root of x minus 2 plus 1. These are radical equations. Here students, you can notice that the expression x plus 3 is under the radical sign. So here this square root sign is called radical sign. So this is a radical equation. Similarly, the expression x minus 1 is also under the radical sign and the expression x minus 2 is also under the radical sign. So this is also a radical equation. Extraneous roots, a solution to an equation that seems to be right, but when we check it by substituting it into the original equation turns out not to be right. Now we will discuss the equation of the type 1, that is square root of ax plus b is equal to cx plus d. We will discuss the procedure by solving the example 1. Solve the equation square root of 3x plus 7 is equal to 2x plus 3. Given equation is square root of 3x plus 7 is equal to 2x plus 3 and is labeled as equation 1. Now we have to simplify this square root sign. So we will take square on both sides. So after taking square, we will get square root of 3x plus 7 whole square is equal to 2x plus 3 whole square. Here this square will be cancelled out with the square root sign and the expression 2x plus 3 whole square is simplified by using the formula a plus b whole square is equal to a square plus 2ab plus b square. So after simplifying, we will get 3x plus 7 is equal to 2x whole square plus 2 into 2x into 3 plus 3 whole square. Again simplifying and get 3x plus 7 is equal to 4x square plus 12x plus 9. Again simplifying and get 4x square plus 12x minus 3x plus 9 minus 7 is equal to 0. Now we will simplify the like terms and get 4x square plus 9x plus 2 is equal to 0. This is the required equation in the standard form. Now we will compare this equation with the general form of quadratic equation, that is ax square plus bx plus c is equal to 0. Here students, after comparison we will get a is equal to 4, b is equal to 9 and c is equal to 2. Now by using quadratic formula, that is x is equal to minus b plus minus square root of b square minus 4ac over 2a. Now by putting the values of a, b and c in this formula, we will get x is equal to minus 9 plus minus square root of 9 square minus 4 into 2 over 2 into 4. Again simplifying and get x is equal to minus 9 plus minus square root of 81 minus 32 over 8. And after simplification, we will get x is equal to minus 9 plus minus square root of 49 over 8. Here students, you can notice that and know that the square root of 49 is equal to 7. So that can be written as x is equal to minus 9 plus minus 7 over 8. Here we have plus minus sign in the numerator, so it can be written as either x is equal to minus 9 plus 7 over 8 or x is equal to minus 9 minus 7 over 8. Again simplifying and get x is equal to minus 2 over 8 or x is equal to minus 16 over 8. This implies x is equal to minus 1 over 4 or x is equal to minus 2. These are the two roots of the quadratic equation. Now we have to check either is there any extraneous root. So by putting x is equal to minus 2 in the equation 1, that is square root of 3x plus 7 is equal to 2x plus 3. Here in this equation we will put the value of x and get square root of 3 into minus 2 plus 7 is equal to 2 into minus 2 plus 3. After simplification we will get square root of minus 6 plus 7 is equal to minus 4 plus 3. Again simplifying and get square root of 1 is equal to minus 1. Here students, you can notice that left hand side is not equal to right hand side, as square root of 1 is not equal to minus 1. So that is not true. So it means that by putting the value x is equal to minus 2 in the given equation 1, it does not satisfy the given equation. So this is an extraneous root. Note, extraneous root is introduced either by squaring the given equation or clearing it of fractions. Now putting x is equal to minus 1 over 4 in the equation 1, we get square root of 3x plus 7 is equal to 2x plus 3. That is the equation 1. After simplification or putting value of x, we will get square root of 3 into minus 1 over 4 plus 7 is equal to 2 into minus 1 over 4 plus 3. Again simplifying and get square root of minus 3 over 4 plus 7 is equal to minus 1 over 2 plus 3. Now we will take LCM to simplify the required equation. So we will get square root of minus 3 plus 28 over 4 is equal to minus 1 plus 6 over 2. Again simplifying and get square root of 24 over 4 is equal to 5 over 2. Here students, you can see that square root of 25 is equal to 5 and the square root of 4 is equal to 2. So 5 over 2 is equal to 5 over 2. Here left hand side is equal to right hand side, so which is true. So on checking we find that x is equal to minus 2 does not satisfy the equation 1, so it is an extraneous root. Thus the solution set is minus 1 over 4. Exercise number 1.4. Solve the following equations. Now we will discuss question number 3, that is square root of 3x plus 100 minus x is equal to 4. The given equation is square root of 3x plus 100 minus x is equal to 4 is labeled as equation 1. Now we will simplify it as square root of 3x plus 100 is equal to x plus 4. Again we have to simplify this square root sign, so we will take square on both sides. So after taking square, we will get square root of 3x plus 100 whole square is equal to x plus 4 whole square. Here this square will be cancelled out with this square root sign, and the expression x plus 4 whole square is simplified by using the formula a plus b whole square is equal to a square plus 2ab plus b square. So after simplification, we will get 3x plus 100 is equal to x square plus 2 into x into 4 plus 4 square. Again simplifying and get 3x plus 100 is equal to x square plus 8x plus 16. Now we will get x square plus 8x minus 3x plus 16 minus 100 is equal to 0. After simplifying the like terms, we will get x square plus 5x minus 84 is equal to 0. This is the required quadratic equation in the standard form. Now we will simplify this quadratic equation, that is x square plus 5x minus 84 is equal to 0, by using midterm breaking method. Now we will compare this equation with the general quadratic form of quadratic equation, that is ax square plus bx plus c is equal to 0. Here students, you can notice that the coefficient of x square is 1. So a is equal to 1, b is equal to 5 and c is equal to minus 84. Now we have to break midterm coefficient, that is b, into two numbers, as here you can see that b is equal to 5. So 5 can be break into two terms as if we add these two terms or two numbers or subtract these two numbers, then it will be equal to 5. And the second condition is that, and the product of these two numbers that we have chosen will be equal to the product of AC, that is equal to minus 84. So if I choose 12 and minus 7, so you can see that 12 minus 7 is equal to 5. Similarly, the product of these two numbers as 12 multiplied by minus 7 will be equal to minus 84. So these two numbers satisfy the given two conditions. So as you know that the midterm is 5x, so it can be written as 5x is equal to 12x minus 7x and minus 84x square, that is the product of these two extreme terms, can be written as 12x multiplied by minus 7x. So the required factorization is x square plus 12x minus 7x minus 84 is equal to 0. Here the midterm 5x is broken into two terms. Now we will pair the terms as x square plus 12x square minus 7x plus 84 is equal to 0. Here students, you can notice that when we introduce the brackets and there is a minus sign before the brackets, so this sign will be changed into plus sign. Now we will take common x in the first expression or first term, so we will get x into x plus 12 minus, and 7 will be taken common as a common, so we will have 7 into x plus 12 is equal to 0. Now again x plus 12 is common in both terms, so we will take x plus 12 as a common and we will get x plus 12 into x minus 7 is equal to 0. Again students, you know that if we have two factors p and q such that the product of p and q is equal to 0, so either p is equal to 0 or q is equal to 0 or both p and q can be 0. This is called factor product property. So by using this property, we can write it as either x plus 12 is equal to 0 or x minus 7 is equal to 0. After simplification, we will get x is equal to minus 12 or x is equal to 7. Now we have to check for extraneous roots. To check extraneous roots, we will put x is equal to minus 12 in the given equation 1, that is square root of 3x plus 100 minus x is equal to 4. Now by putting the values of x, we will get square root of 3 into minus 12 plus 100 minus into minus 12 is equal to 4. After simplifying, we will get square root of minus 36 plus 100 plus 12 is equal to 4, that is equal to square root of 64 plus 12 is equal to 4. And the square root of 64 is equal to 8, so it can be written as 8 plus 12 is equal to 4. And again simplifying, we will get 8 plus 12, that is equal to 20 is equal to 4. As you can see that the left hand side is not equal to right hand side, so this is not true. So x is equal to minus 12 is the extraneous root. Now putting x is equal to 7 in equation 1, we get square root of 3x plus 100 minus x is equal to 4. After putting the value of x, we will get square root of 3 into 7 plus 100 minus 7 is equal to 4. That is equal to square root of 21 plus 100 minus 7 is equal to 4. Again simplifying and get square root of 121 minus 7 is equal to 4. And square root of 121 is equal to 11. So 11 minus 7 is equal to 4. This implies 4 is equal to 4. Here students, you can notice that left hand side is equal to right hand side. So this root satisfies the given equation. So x is equal to 7 is the true root of the equation. Thus the solution set is 7. Home assignment, students. Question number 1, 2, 3 of exercise 1.4 are related to type 1. So do it by yourself. Thank you. Stay blessed.